Dear students, today in this session 5, we will going to discuss about some of the aspects regarding quantum mechanics. This is Unit 1, Quantum Mechanics of second semester MSc syllabus of QM University. In the Quantum Mechanics 1, we will understand some of the fundamental aspects, and myself, Dr. Ganesh Acharya, Assistant Professor, Department of Chemistry, IDSG Government College, Chikmagaluru. So, the outline of today's class is to understand what are eigen functions and eigen values, and how the Hamiltonian property of operators can be understood, and we will going to see 6 postulates based on which many of the concepts in quantum mechanics are explained. Now, let us see what is an eigen function. In general, the whole system in quantum mechanics is explained completely by a wave function. You all know that. Now, when an operator operates on the wave function, which gives a function that is same function multiplied by a complex number lambda, then the wave function is called as the eigen function. Alright, so that means a well-behaved wave function psi of a system is operated by an operator A such that the result is the product of a constant, say lambda, and the wave function psi itself. Okay, so that is A psi is equal to lambda into psi. Hope you understood. Now, let us explain this in a very simple manner. When a wave function is operated by an operator A, it gives the same wave function multiplied by a constant. Then the wave function is called eigen function, right? Here lambda is a complex number and psi is called eigen function, right? Now, let us see what is eigen value. Suppose a well-behaved wave function psi of a system is operated by an operator A, capital A, such that the result is a product of a constant, say lambda, and the wave function psi itself. Alright, that is when a wave function psi is operated by an operator capital A gives the same wave function multiplied by a constant lambda. Then the constant obtained is a complex number and is called the corresponding eigen value. Alright, so this is the definition of eigen function and eigen value. Alright, now if suppose you have a set of eigen functions, say psi n, here n may be an integer, of an operator, say A. There is an eigen value lambda n associated with each function. Then you will get an equation A psi n is equal to lambda n into psi n. This equation is called eigen value equation. Alright. Here n may be any integral value. So eigen value equation can be written in the following way, that is, an operator multiplied by a wave function gives a constant multiplied by same wave function. So this is the eigen value equation. Okay, let us take an example of the wave function psi n is equal to sin nx. Okay, you can show that this is an eigen function corresponding to an operator d square by dx square with an eigenvalue minus n square. Okay, here d square by dx square is an operator. The wave function is sine n of x. Then you can show that psi n is the eigen function. Let us see how you can show that. So an operator acts on the wave function psi n, that is d square by dx square of sine nx. When you double differentiate this, you will get, so when you differentiate once, you will get n into d by dx of cos x, that is differentiation of sine nx is cos nx, that gives minus n square into sine nx. That means when you operate the wave function by this operator, you will get the same wave function sine nx multiplied by a constant minus nx square. So here sine nx can be called as eigen function and minus n square is the eigen value. Similarly, let us take one more example. E to the power I kx is an eigen function of an operator minus I h cross dou by dou x. Okay, so when an operator minus I h cross dou by dou x of, it acts on the wave function e to the power I kx, it gives my h cross k square e to the power I kx. So here this is a constant multiplied by the wave function e to the power I kx. So therefore e to the power I kx is the eigen function. Alright. Now what is Hamiltonian operator, or how you can understand Hamiltonian property of an operator? So in our one of the classes, we have derived the time dependent Schrodinger equation, that is I h cross dou psi by dou t is equal to h psi, right? So here what is h? H is called as Hamiltonian operator of the system. Now for a single particle, say of mass m having potential energy V, the Hamiltonian is given by the sum of kinetic energy operator and the potential energy operator. Alright. Now the kinetic energy operator is given by minus h cross square by 2m into del square. Okay. And the potential energy operator is given by V of r comma t. So Hamiltonian operator is nothing but the operator corresponding to the total energy of the system, right? The total energy operator of a system is called the Hamiltonian operator, and the Hamiltonian operator is the sum of kinetic energy operator and the potential energy operator. Now the Hamiltonian equation, that is in the form of an eigenvalue equation, can be written as h psi n is equal to En into psi n. Okay, where psi n is the eigen function, or in general it is a wave function, and En is the total energy of the nth state, right? So Hamiltonian operator is given by minus h cross square by 2m into del square plus V of r comma t, and Hamiltonian equation can be written as h psi n is equal to En psi n, where En is the total energy of the system in the nth energy state, right? And En remains constant in time. The solution psi n are called stationary states. Okay, so this is the explanation for Hamiltonian property of the operator. Hope you understood. Okay, now let us move on to some of the fundamental postulates of the quantum mechanics. Now all the principles or theorems are depending upon 6 fundamental postulates in quantum mechanics. Now the first postulate is very simple. The state of a quantum mechanical system is completely described or completely specified by a wave function. That is the first postulate. The state of a quantum mechanical particle is completely specified by a wave function. That is the first postulate. So, only a spatial coordinate is considered. The probability that particle will found at a time t0 in a spatial interval of width dx centered at x0 is given by psi star into psi into dx. Okay, that is a probability. In simple, the state of a quantum mechanical system is completely specified by a wave function psi of x comma t. That is the postulate number 1. And the second postulate is described in a very simple way. That is, for every observable or a measurable quantity, there corresponds an operator in the quantum mechanics. Okay, for every observable like position, momentum, energy, etc., there corresponds an operator in quantum mechanics. That is the second postulate, right? For every measurable property or for every observable, there corresponds an quantum mechanical operator. That is the second postulate. And third postulate is about the measurement of observable. So, in any single measurement of the observable that corresponds to the operator A cap, the only values that will ever be measured are the eigen values of the operator, right? So that means when you use an operator on a wave function, the measured values corresponds to the eigen values of the operator. That is a third postulate, right? In simple, when you operate a wave function, say psi with the operator a cap, it gives the measurable quantities in terms of eigen values corresponding to the operator. So that is the third postulate. And fourth postulate is to describe the state in terms of a wave function. That means the average value or the expectation value of a measurable quantity in terms of wave function is given by an equation. Okay, so if the system is in a state described by the wave function psi and the value of the observable, say small a, is measured once on each of many identically prepared systems, the average value or the expectation value of all the measurements is given by mod of a is equal to integration of minus infinity to plus infinity psi star a cap psi into dx divided by integration of minus infinity to plus infinity psi star psi into dx. So this is the equation by which you can find out the expectation value of an observable. Alright. So fourth postulate is about the expectation value of an observable. Right. Then the fifth postulate is about the Schrodinger equation. So the evolution in time of quantum mechanical system is governed by the time dependent Schrodinger equation, and it is given by h cap psi is equal to I h cross dou psi by dou t. So this is postulate number 5. The evolution in the time of quantum mechanical system is governed by the time dependent Schrodinger equation. H cap psi is equal to I h cross dou psi by dou t. That is the fifth postulate. And the last postulate, that is sixth postulate, is the wave functions describing a many electron system must change sign. That means be antisymmetric under the exchange of any two electrons, right? That means the wave function changes its sign by exchange of any two electrons in a system, that is in a many electron system. So these are the 6 fundamental postulates of quantum mechanics. So to summarize all these postulates, the first postulate, the quantum mechanics is based on a set of postulates or hypotheses. The first two postulates establish the role of the wave function in quantum mechanics. And the third postulate establishes a connection between each mechanical variable and a mathematical operator. And the fourth postulate provides the means to obtain information about the value of mechanical variables. And the fifth postulate concerns the determination of the state of system by experimental measurements. And at last, the sixth postulate tells about the exchange of electrons in a system. Many electron system gives rise to change in its sign. Okay, so this is about the postulates of quantum mechanics and what are eigenvalues, eigenfunctions, and what is Hamiltonian operator. So we shall stop it here, and we shall continue the discussion in our next class. Okay, you can go through these few references to understand the concept in detail. Thank you.